Now let me discuss these equations, and through the discussions, we can have a general idea how to deal with these type of equations. Sine x equal to I, cosine x equal to I, tangent x equal to I, secant x equal to I, tangent x equal to 2i's. Now, let's start with sine x equal to I. It's obvious that we can have a cosine x is equal to square root, right? 1 minus I squared. Since positive sign could be in the first and the second quadrant, so cosine could be both positive or negative. Right? So this one is equal to plus or minus root 2. Now then, e to the ix is equal to cosine x plus I sine x, which is equal to plus or minus root 2 plus I squared, which is equal to plus or minus root 2 minus 1. So Ix is equal to log plus or minus root 2 minus 1. Right? Now then we have two different cases. One is a log root 2 minus 1. The other one is log negative root 2 minus 1. Yeah, this one is okay because root 2 minus 1 is positive. The other one is equal to log negative 1 multiplied by root 2 plus 1, right? Yeah, we will discuss separately. So that means Ix is equal to, the first case is okay, natural log root 2 minus 1. Now this is a log negative 1 plus log root 2 plus 1, isn't it? Yeah. Okay, good. And this one is okay, log root 2 plus 1. This one, log 1 is what? Log 1 is log e to the pi I, right? So this is equal to pi I, right? That is natural. That is log negative 1 is pi I, and plus log root 2 plus 1. Now, log root 2 plus 1 is equal to log root 2 plus 1 times root 2 minus 1 divided by root 2 minus 1. So this is equal to log, this is square minus 1 square equal to 1. This is log 2 minus 1. So this one is equal to negative log root 2 minus 1. So this is equal to negative log, okay? So this one is equal to this. So my Ix is equal to natural log root 2 minus 1 and pi I minus log root 2 minus 1. Yeah, this is equal to this. Therefore, x equal to this times log root 2 minus 1. This is equal to pi minus I log root 2 minus 1. So this one is equal to negative I log root 2 minus 1. This one is equal to pi plus I log root 2 minus 1. So my x is equal to this or that. Well, now this result is coming up when I'm considering the cosine x. There are two possibilities, right? Now, if I don't consider two possibilities in the beginning, in the first place, I just consider root 2. Then I have only this, right? If I consider cosine x is root 2 only in the first quadrant, not the second quadrant, then it comes up the x equal to negative I log root 2 minus 1, right? When I'm consider x is in the first quadrant. And then I'm considering the second quadrant because sine x is equal to sine pi minus x. Therefore, pi minus this is also solution. That is minus this root 2, which is exactly equal to x plus I log root 2 minus 1. See? So this result can come up when I consider the second quadrant later. So what I want to say is that when we solve this equation, we can consider x is lying the first quadrant and the second quadrant at the same time. Then you come up the two solutions, right? Or I'm considering only the first quadrant, and then at the end, at the final solution, I am considering the second quadrant, and I still come up with this solution. One way or the other, I get two, you know. So I hope you understand what I mean. Then I'm considering the general solution because this is just principal solutions. So x is equal to that two general solution. This is minus I log root 2 minus 1 plus 2n pi, or x pi plus I log root 2 minus 1 plus 2n pi. So that is the final answer in general answer. Well, I hope you understand what I mean, because I'm considering the second quadrant, I'll get these two solutions. If I'm considering the first quadrant, and I still come up with the second quadrant by subtracting from pi. See? You get the two solutions anyhow. All right. I hope you understand this one. Okay. And now and then consider second case, cosine x equal to I. Right? And of course, we can do the analyzation from beginning. This is equal to sine x equal to, while I'm considered first quadrant, because cosine is positive, sine could be negative. The x could be the fourth quadrant. I'm considering the fourth quadrant at the end. So I'm not considering here. So I'm taking only positive case, right? Positive 1 minus I squared. So let's go to root 2. That is the first quadrant. The fourth quadrant I'm considering later. Now then, e to the ix is equal to cosine x plus I sine x, which is equal to I plus the root I, right? Yeah, equal to I 1 plus. That's correct. Then my ix is equal to log I 1 plus or minus. So this one equals to log I plus log 1 minus root 2. Then x is equal to 1 over I log I plus 1 over I log 1 minus plus log 2. Yeah, this one is equal to half pi, right? Because this is equal to half pi I e to half pi I. And this one equal to negative I. Yeah. Then I'm considering the fourth quadrant. So x is also can be equal to negative x, right? Equal to negative. So this one is equal to negative half pi plus I. Wow, this is also solution when x is the fourth quadrant. So I'm not considering the fourth quadrant, but I'm considering the fourth quadrant here. So in general, so x is equal to plus or minus root 2 minus I. Well, that is general story plus 2n pi. Sure, this one or negative that one, you could see both. Well, if we know sine, this is a solution for sine x, and cosine x is equal to sine x half pi minus x, right? Very easy. We just take away from half pi, you get a solution. So x equal to, this is solution for sine x. So this is equal to half pi minus this, right? Negative root 2 minus 1. Yeah, plus n pi. This is okay. And pi minus plus I sine root. See, that will also do, no? So this one is equal to, this equal to half pi plus I log root 2 plus 1, right? Plus 2n pi. It's okay, n could be negative. This will be, this minus that will be negative half pi minus I log root 2 plus minus 1 plus 2n pi. See, we get the two solutions. And this 2 root 2 minus 1, yeah, that's correct. This is sine. This is, did I copy wrong? This is plus, right? So plus. So this is plus. Now, this is equal to negative root log of root 2 minus 1. See, you get the same thing, but anyhow. So we get two solutions for the cosine by using this result if we know the sine. Okay, these are two solutions for the cosine. Now the tangent. Tangent x is equal to I, and we know that tangent, this is x, right? Tangent x equal to I, so this is I, this is 1. So this one is equal to 1 plus I squared. So this is equal to 0. If this is equal to 0, well, sine and cosine does not exist. Therefore, this one has no solution. Because the sine cosine is not defined. It's a very, very, very nice way to get the solution. But if as I said in the beginning, well, we discussed cosine tangent equal to I. That's different. If tangent x is equal to 2I, then this will be different. The sine cosine is defined. This is a 2I, this is x, this is 1, this is 1 plus 2I squared is a negative 4, right? So it's equal to I root 3. Now it's different. So cosine x is equal to this over that, right? This is 1 over root 3I. Sine x is equal to this over that. This over this is equal to 2 over root 3. Yeah, correct. And e to the ix is equal to cosine x plus I sine x, which is equal to 1 over root 3I plus I over 2I root 3. Yeah. So this one equal to negative I root 3 plus 2I root 3. is equal to I over root 3. Wow, good. That is e to the ix. Therefore, ix is equal to log. So this one is equal to log I plus log 1 over root 3. Right? Log I is equal to half pi I. Right? Yeah, minus log 3, root 3. So my x is equal to half pi minus 1 over I is positive I, right? Wow. Now, here I'm considering the first quadrant. Cosine, tangent is 2i, positive, then this could be what? This could be the third quadrant. Therefore, x could be what? This plus pi, right? And I root 3 plus pi. Yeah. See, both are okay. This is in the first quadrant. This is in the in third quadrant. And then we plus 2k pi, right? That will be general solution. Yeah, root I log root 3 plus 2n pi. See, this will be third pi plus I log root 3 plus 2n pi. See, that will be the general solution. Okay, it's a very good by using this way to discuss these type of equations. I think there's one more left. That's about a secant. The secant. Now, the secant x equal to I. We want to find x, right? Secant, yeah. Secant. That's easy. Draw a triangle. This is x. Secant x is equal to I, so this is I. This is equal to 1. So this one is equal to I square minus 1 square, right? So equal to root 2I. Yeah. I'm considering the first quadrant. See, from the previous cases experience that we considered first quadrant, then we add up the adjustment for the final answer. This means to consider this is true or not. This is square minus 1, so it's minus 2. Minus 2 square root is equal to this, correct. So sine is equal to sine squared is this over that, right? This over that. This is root 2. Cosine is equal to 1 over I. 1 over I equal to negative I. Well, don't forget that we're analyzing the first quadrant, and at the end we make some adjustment for the fourth quadrant, right? Because secant is positive, could be the fourth quadrant. Now then, e to the xi is equal to, well, is equal to cosine negative I plus I times root 2. Yeah, times sine I. Yeah, this is equal to I is common factor root 2 minus 1. Yeah, so ix is equal to log I plus log root 2 minus 1. So this is positive. Is this okay? So x is equal to log I is what? E to the log e to the half pi I. So this is half pi. Divided by I is multiplied by I. Yeah, that is the principal solution in the first quadrant. Yeah. And negative is also a solution, right? So this is also solution. Negative to I plus I. This will also be a solution. Then we add the, right, the, but combine them together is plus or minus root log natural 2 minus 1. Yeah, plus 2n pi. That will be general solution. See? Very good. And I think after these discussions, we know basically about those solving these equations in general.